You can build a corporate training program with the highest production value in the world, but if the foundational architecture is fundamentally flawed, the entire structure will inevitably collapse under its own weight. The structural error in modern instructional design is surprisingly basic. We routinely apply pedagogical frameworks, systems engineered for children, to adult corporate learners. The measurable result is a landscape of mandatory training modules with abysmal engagement rates, failing entirely to drive long-term behavioral change. To design education that actually works for a mature workforce, we have to abandon pedagogy completely and adopt an evidence-based approach known as andragogy. Andragogy defines the specific structural and cognitive mechanics that govern how adults acquire, process, and retain information. To fix our courses, we first need to map the structural matrix separating K-12 learning principles from adult cognitive requirements. Second, we will deconstruct two scientific heuristic methodologies that successfully trigger cognitive adaptation in adults. Failing to address this distinction often results in training programs that remain theoretical artifacts, largely disconnected from the practical realities of the adult learner. We need a comparative framework to pinpoint where traditional course design breaks down. Starting with knowledge and timing, pedagogy focuses on abstract theory for a child's eventual use in adulthood. Adult learners require the exact opposite. Information must have immediate practical application to solve current professional tasks. This distinction was formalized by foundational researchers like Malcolm Knowles, who proved that adult learning must be rooted in immediate relevance. Next, look at motivation. The K-12 model relies on external rewards like grades, gold stars, and pleasing authority figures. Adults are internally driven. They invest time in learning specifically to elevate their social or professional status in the real world. This dictates a different communication dynamic. In a pedagogical classroom, the teacher sits atop an absolute vertical hierarchy. In andragogy, the instructor acts as a horizontal mentor. Adult learners bring valid life experience and expect to be treated as peers. Because of these differences, pedagogical programs are entirely rigid, standardized from start to finish. Adult programs must be modular and flexible, constantly adapting to shifting learner motivations and real-time feedback. If an instructional designer forces an adult audience through that rigid top-down structure on the left, they violate the learner's cognitive architecture, immediately destroying any chance of engagement. To satisfy these specific adult requirements, we turn to heuristic methodologies like problem-based learning. The core operating principle here is that adults require active cognitive search and discovery, rather than the passive reception of information. We trigger this using a problem task. This creates a literal cognitive gap between current knowledge and the new data. By forcing the adult to bridge this gap independently, the brain forms lasting neural pathways impossible in a passive lecture. While a problem task provides specific variables, a problem situation removes those safety nets. It presents a scenario lacking clear variables, requiring immediate creative decision-making. These environments force the adult to abandon rote memorization and synthesize new solutions on the fly. However, this methodology carries a strict risk constraint. It will fail if the instructor does not accurately measure the adult's baseline experience beforehand. Throwing an unprepared adult into a complex problem situation causes instant cognitive overload and withdrawal from the course. When properly calibrated, problem-based learning forces the transition from passive observation to the active applied solving required for adult skill retention. Our second methodology, project-based learning, takes this cognitive search and scales it up to a collaborative level. This framework forces adults into self-directed research environments, permanently removing the instructor as the sole source of truth. The structural rule for designing these projects relies on balancing the target competency against the project difficulty. As the required skill becomes more complex, the difficulty and the required learner autonomy must scale precisely in tandem. In practice, placing adults into collaborative projects will immediately expose uneven prior experience among the group. This shifts the instructor's role entirely. They are no longer lecturing, they are actively managing the friction and social dynamics created by this uneven experience. If this friction goes unmanaged, it derails the project momentum and leads to high dropout rates. Despite the inherent friction, Project-based learning accurately simulates the complexity of real-world professional environments, bridging the gap between theoretical training and actual job performance. This brings us to a major tension in modern educational technology: the conflict between what learners say they want and what cognitive science proves works. We call this the CusDev trap, the flawed trend of relying purely on customer development surveys to dictate how a course is taught. When surveyed, adults will often request passive video lectures and multiple choice tests, simply because those formats demand significantly less cognitive effort. That preference stands in direct opposition to the rigorous requirements of cognitive science and andragogy. We must establish a strict professional boundary. Market research identifies what skills are needed, but we rely entirely on science to define how those skills are taught. Theorists like Lev Vygotsky, through concepts like the zone of proximal development, provide the scientific justification for pushing adult learners beyond their preferred learning styles. To measure whether a chosen methodology is actually working, we use frameworks like Bloom's taxonomy. Almost all meaningful corporate training goals, like driving behavioral change or strategic thinking, exist at the very top of this cognitive pyramid, in the zone of synthesis and creation. You cannot accurately test these high-level synthesis skills using low-level tools like multiple-choice quizzes. Reaching the peak of Bloom's pyramid requires the high-friction environments found in problem-based and project-based learning. We must stop designing courses based on intuition, industry trends, or the path of least resistance. True educational design relies strictly on the proven architecture of adult cognition. It is the only reliable method to engineer real-world behavioral change.